less than or equal to negative 5. So what you guys are looking at here is what we call set notation. Okay, everybody okay with these two examples? Set notation, is that easy? You just have to use the set, the brackets, x with the line. Anyway, okay. Make sure we're in focus and the audio's on. The audio was on. Where's our headphones? Thank you. My daughter she does this. She always takes the headphones out of my bag. So all my headphones she always puts it somewhere else. Do you guys do that at home to your parents? Take their things? Huh? You take all your parents' stuff and she's got to listen to her music or something? Yeah, the audio's on. Good, thank you. I already have some of these lectures, the audio was off. So here we go. All right, we're going to now talk about our interval notation, okay? So let me erase this. And you guys are going to use this notation in intermediate algebra. You're going to use the notation in maybe college algebra, if that's the course you're going to take. You're going to use it in pre-calculus, Math 260, if that's the course you're going to take. You're going to use it in calculus, if that's the course you're going to take. You're going to use set notation, you're going to use graphing, and you're going to use this interval notation. So let me describe interval notation for you guys. Okay, you guys ready for this? Sometimes in the homework, it'll even say to you, actually all three. So it'll say in the homework, solve this linear inequality and describe your solution in set notation, graph, and interval notation. So they're going to want you to do all three in some cases. And the reason they want you to do all three is because they want you to be very proficient in the description of a solution, because this concept of solving linear inequalities, you're going to see, I talk about it the first day in Math 125. We actually review all of this the first day of Math 125. So what you learn in 115 now with this, believe me, it's going to be around for a while. It's going to be around for a long time. So let's talk about interval notation. Here's the deal with interval notation. First of all, I guess the part you guys first have to learn. Interval notation here, first of all, is, let's go back. Remember, if we had a graph, numbers that are, let's say, greater than 4, and I'll put greater than or equal to 4. I already know you have 0 here, 4 would be over here. What are we going to do with that circle? Are we going to shade it, or are we going to leave it open? So that means we have a closed circle. We shaded that. Numbers greater than 4 live where? To the right or to the left? Well, numbers greater always live where? To the right of the number. 4 is on the list. 6 is on the list. 20 is on the list. 1,000,000's on the list. So we got the graph. And yes, you may say, oh, Mr. Judge, isn't that my description for set notation? Yes, it is. This is still the description for set notation. But we're now going to talk about what? Interval notation. So here's what I want to say to you. You want to read this always left to what? To right. So when you're working with all of these expressions, really, your description, you want to read left to right. The graph, you look at it left to right. So we're going to work in that capacity left to right, in the same way that we mostly read, okay? Or we should read, left to right. Okay, fine. What does that have to do with interval notation? Well, what we are describing is simply numbers that are greater than or equal to 4. They have to be greater than 4 or also what? Equal 4. We're describing the numbers that are shaded. Is that true? So if you're walking from the left side to the right side, way over here, can you describe to me on your feet what was shaded? In other words, as you move left to right, are any of these numbers over here shaded as you're walking? No. Only starting where is it shaded? Exactly at 4. So at 4, that's when you start the what? The shaded business. Is that true? And as you're walking here, starting at 4 on your feet are in this, if you want to think of this as water or something, your feet are wet. 4, when does it stop? It never stops. Is that right? This keeps going what? Forever. So if this represented water and you're walking left to right, your feet get wet starting at 4 and it goes on. We put a comma here. It goes on forever. You guys know how we describe forever? We use this symbol called the infinity symbol. So we're describing to people, okay, what's being shaded starts at 4 and what? Never ends. You with me on this? We communicate the concept of starting exactly on 4 with what we call a square bracket. That means include your 4. And what we use here for the infinity is actually a parentheses, because infinity is actually an idea. It's not even a number. It's not finite. So we don't actually put the bracket ever with infinity because it's just not a number. So what we're looking at here is the interval notation of the shaded numbers here. Starts at 4 and what? Never ends. Start at 4, never end. Square bracket because you include the 4. And by the way, some of you guys may remember from some algebra classes you may have had in high school. You may say to me, hey, Mr. Judge, why do you use this open circle, closed circle business? I haven't seen that notation since high school. Well, okay. The reason I actually use it to describe it is because I want people to think about the idea of including 4 or not including 4. But you may look in back of this book because you're in a college algebra course. In back of the book, you're not going to see necessarily, or some algebra books, you're not going to see a closed circle. What do you think you're going to see? You're going to see this what? Square bracket. Where do you think they got it from? The interval notation. Okay, so I want to show you guys that I will start to write it this way, back in that high school mode, but it's really, in your college book, a square bracket. What you're describing are numbers that are shaded as you read this left to right. It starts at 4, includes 4, and it goes on what? Forever. Okay, you guys okay with this notation, this interval notation? Anybody have any question on this? This is what we call what? The interval notation. Compare this problem to, or this setting to, the description of numbers that are strictly greater than 4. This is greater than 4 now. When you graph this, earlier you said here's where 0 would be. You told me here's where 4 would be. My reference point, my open circle, numbers greater than 4 live to the right of 4. Okay, and that goes on forever. But we didn't shade this in because we do not include the 4. Is that true? Okay, this is your graph. Now, if we had to describe this in terms of an interval, again, you're gonna read this how? Left to what? To right. And you're walking on the real number line. When do your feet get wet? Well, let's think about this. As you move left to right, when do your feet get wet? Do they get wet at 4? Not exactly, because we're not including 4. Is that true? They start to get wet where? After the what? 4. So let's still list the 4 as a reference. And this goes on all the way to what? Infinity, forever. As we're walking, our feet are wet forever. We already know this is a parentheses. But what I'm getting at is this. If we do not include the 4, what symbol do we use? The square bracket? No, we use the what? We use a parentheses symbol. So what this means to the reader is that, okay, something special is happening around what? 4. What is that special thing? Well, don't include the 4, but include the numbers that come slightly what? After. So what this means is as you're walking on the real number line, your feet do not get wet at 4. They start to get wet slightly what? After 4, and it never ends. So remember, this is how I kind of want people to think about it. You're walking on this real number line. You're describing really what's shaded. This is a description of what's shaded in terms of what we call interval notation. So here's our notation. Okay, anybody have any questions on this one? You guys like that? You do? Notation. It's kind of it's like learning grammar, I guess. Numbers less than what? -3. You're learning some grammar here. Let's put less than or equal. You're learning the form of how we communicate in mathematics. Just like when you learn about grammar, you're learning how to communicate in English. That's why I say that. Okay, so let's describe numbers that are less than or equal to -3. When we graph these things, here's where 0 would be. -3 is on the left, right? Open or close circle? Closed. Good, thank you. How do you know it's closed? Has it equal? What numbers are smaller? Numbers that live to the left or numbers that live to the right? To the left. Good. I still want you guys to consider the fact that you're still walking from what? From left to what? To right. We're still with that orientation. So we're going to work left to right. We're going to walk left to right. We're going to read left to right. This left to right business comes into play. All right, you okay with this? Okay. All right, let's see. Notation. Whew. What's going on now? What do you guys think? What do you guys think about this? What's going on now? Remember we're talking about describing the shaded region of this real number line? And we're thinking about that. Maybe that's water. And you started on the left. What do you guys notice? Are your feet wet where you started? Is that right? So it doesn't matter where you started to the left. Your feet are wet. Wet. So if you start with your feet wet, and it didn't matter where you started, because this line goes where? What direction is that? Well, forever in what direction? The negative. That's actually, ladies and gentlemen, negative infinity. So the direction over there is negative infinity. That means it's negative, but it goes on what? Forever in the negative direction. Just like this is positive infinity, it goes on forever in what direction? The positive direction. Okay, so you may want to say, oh, here's my positive direction, by the way. Here's my what? Negative direction. So we start at negative infinity. Our feet are wet. It doesn't matter where we started to the left. They're wet. And then as we walk to the right, what's the story? As we walk to the right, what's the story? We get closer and closer to what number? So we write down the reference of -3. Are our feet still wet at -3? How do you know? It's shaded. So put a bracket, a square bracket. And infinity or negative infinity always has a parenthesis. So what you're looking at, ladies and gentlemen, is interval notation for this kind of picture, this scenario. Okay, you okay with this? Anybody have any questions on this example? No? You sure about that? Is that still easy? We got one last scenario though. Or a couple of. Anybody have any? Everybody's okay with this so far? Right? What if I gave you, for example, can I erase this one? Let's erase this one. We're talking about interval notation. Let's say now, let's look at a problem that's related to this. Let's look at the example where we're trying to describe numbers that are strictly less than negative 3. What's the difference between this example and the one that we just did? Notice when we graph negative